So this is DC chapter 1. It's really summarizing chapters 1, 2, and 3. And we're going to start just to give you a general overview what electronics is, okay? So the very first thing that you should know is what is Ohm's law? So the main formula for Ohm's law is the following. I is equal to V divided by R. And you're like, well, what is I? What are you talking about? So this is Ohm's law. This is the general equation. You can rewrite it in many different ways, but let's go and look at what I is, V is, and R is. So I stands for current. V, or sometimes they say E in the book. E or V is voltage. And R is resistance. Okay. So current, what it measures is called amperage. So it measures amperage, or sometimes they call it amps. And they have the unit is A. The unit is like when we're doing time, it could be seconds or little s. That's what the unit is. And then for voltage, we measure volts. And the unit is a V. Resistance measures ohms. And it is the Greek letter omega. So it looks kind of like that. I'm not maybe writing it perfectly, but you can look at the book and it writes it like that. The Greek letter, this is a Greek letter, omega. Okay. So that's the unit for resistance. Okay, so now we know the definitions. We know what I is, voltage is, and resistance is. You can rewrite, remember, the units for current. We're doing voltage divided by resistance. The units for current is going to be A. So right here, we put the little letter A for my units. Okay, if I want to find voltage, I've had students that were, what is it called? Electricians, or students that have told me that they did not do well with formulas. So there is this triangle formula, or this triangle that they put. And so what happens here is if you're trying to find current, so you're trying to find this formula, you cover this. So cover that, and then you'll see that V divided by R will be current. And that's how you get this formula. And this, from this triangle, you can also see what voltage is. So now we're going to cover voltage right here. So just pretend we're covering that. And then you see I, R. They're next to each other. So there's like a multiplication thingy right there. And that's how you come up with this formula right here. So if you cover in the triangle, the V, you'll find I times R, okay? So there's just a different way of writing Ohm's law. This is also Ohm's law, but the unit is now voltage because this is voltage. It measures volts and the unit is V. Yes? Okay, make sure I'm not going too fast, okay? So now we're going to find resistance. We're going to cover the R. And if you notice, I'm going to erase that little X right there. Right there. And now, if you notice this, oops, sorry, I meant to do it in black. If you notice, if I cover that, then that's going to be V divided by R. So the line looks like an R. Hold on, let me I'm trying to do something over here that I forgot to do. Oh, it's too hard. Okay, I'm trying to put a pencil gripper on my Apple pen because it's too slippery and it's having a hard time. Oh, come on. Sorry. Okay, let's try that.
You can do it.
Huh? I'm sorry?
I said you can do it.
I know, huh? It's new, so it's a little hard because it's slippery. Okay, well, this is not gonna work to wait because it's too, now it's too, okay, we'll see what happens. So there, and here's the line. So V divided by I. And so the amperage, the unit for that is going to be omega, because this is resistance, measure ohms, and we have omega. Does everybody see that? Yes? Okay. So there you go. You have learned your well, it's one equation, it's just written in different ways. So now we're going to do definitions, okay? So we're going to write the generic definition. If you go look in the book, it's a little fancy. This is all we're writing right now is going to be on your first exam. Your first quiz, I'm sorry, which is today after at 3:30 and closes on Sunday at 11:45, and you can take it up to 3 times. All right, so the current says that is the flow of electrons in one direction. And you're like, what does that mean? So my analogy here is water. So think of a river, okay? They always do analogy with water and electricity. So think of a river, and as you can see, the water flows in one direction, right? So it just flows in one direction. So pretend the water is the electrons, okay? Then we're going to talk about resistance. So resistance is going to be the ability to resist the flow of electrons. So how does this compare to my water analogy? So think about, there's a river, and if there's no rocks, there's no beavers building a home, or there's no pieces of trunk of a tree, the water flows very without any type of resistance. But if there's any rocks, or the beavers are making their own little house, then there is resistance. So the water has to go around the rocks, or around the trunk of a tree, or things like that. So that is what resistance is, the ability to resist the flow of electrons. Okay. Then the voltage is going to be the force. So the force that gets electrons to flow. So in this analogy with the river, the way you would think about it is like a dam. So pretend that at one end of the river, or somewhere in the river, there's a dam, and you can control how much water or how much force is in that river of the water flowing, depending on how much water you let, you can manipulate how much water is going to go through the river. Okay. You can also do the analogy of a water hose. So you have a water hose in your garden, and so water comes through the water hose, right? If you open the faucet, that's the force, to let the water through. And then the resistance is, if I'm using the water hose that most people use at home, it's pretty small, only a certain amount of water. The diameter is small, so only so much water can come out. But if you work and you're a fireman, the water hose that they use, they have a big diameter, and so there's less resistance, so more water comes out. Yes? Does that give you kind of a picture? Okay, so you need to know these definitions in order to take the quiz. So it's going to be like multiple choice, or match the word to the definition. Yes? Okay, very good. All righty. So this is a table that I have that starts filling. So we kind of filled this out on the other page where I means that it's current. So we're kind of reviewing, and it measures amperage or amps. What was the unit? Who can tell me that? Was it a Z or what?
A.
It's an A. Usually it's a capital A.
Capital A. Hmm.
Yeah. And then here, we're going to do symbols in a minute. Here, V or E is voltage. It means voltage, and it measures volts. So what's the unit for that? Is it Z?
V.
V, very good. And what about resistance? R means resistance. It measures ohms. So what is the unit?
Omega.
Omega, the Greek letter omega. So we didn't talk about this one, but this was very important also. It is power. So this guy is power, and it measures watts, and the unit is big W. Okay. So let's look at the symbols. So the symbols for current is going to be an arrow. So it doesn't matter. Current flows in many different directions, okay? So it could be one of those. And sometimes they have a little I next to it to indicate that that is the flow of current, okay? Okay, we're gonna do resistance first. So this is a symbol for the resistance. It looks like that, or it can go in this direction, and it's a resistance, okay? Usually you have a little R with the value of 10 ohms, maybe R 20 ohms or something like that, okay? There's no symbol for power, so it's not applicable. So there's none, we'll just say none, okay? Voltage is a different story. Voltage is going to be a voltage source, like your battery is volts. It's in volts. We measure in units of V, okay? So your battery, I'm gonna do it in purple, just so you guys can see, this is V. And usually it has a long line and a little small line, a long line and a small line. So it's a pair, and it's only this part, and then of course it has a little line to connect it to something, okay? The first big line is positive, and the little line is negative. And so in a battery, there's 3 sets of these so in a regular battery, we have 3 cells of being, I think, 4 volts each. So to make 12 volts, you have 3 of these patterns of a small and a long line. So in the battery, you always have a positive side, which is in red, and a negative side, which is negative. Don't put positive, negative, positive, negative. Only one positive and only one negative. Yes?
So is that 2 batteries then? Like one big line, one small line, or is that just one battery?
It's only one battery, but it's a cell.
Oh, okay, okay.
Yeah, so I'm only drawing this way, but you know, this guy could be in many different ways. It could be shown just like that with one cell, and it's just like representation. It's a symbol, right? So so when we're doing our symbol stuff, it's like that. Or sometimes they go nuts and they start doing a bunch. 1 set, 2 sets, 3 sets, 4 sets, but it's going to tell you what the value is. So you don't count the number of cells. You just want to know what is the positive, which is the negative, and this could be like 12 volts. This could be 12 volts, and this could be 12 volts. You know what I mean? It's just a symbol, okay? All righty. So now we're going to move to the second portion right here. What does DC stand for? What does DC stand for?
Direct current.
Direct current. So we are doing direct current. So if you didn't know, now you know, direct current. And if you had a 12-volt battery and you saw it in this electronic little TV, it's called an oscilloscope. And usually we use it for the AC class, which is the second class. DC is always our first class. It would just be a straight line of 12 volts. So no matter what time it is on the x-axis, this guy would remain 12 volts until it gets drained, right? And it goes down below 12 volts. But, you know, it's a straight line. So if you saw it in an oscilloscope, which is like a little TV monitor, and we're going to see that when we go to class, it would just be a straight line. It would always be 12 volts until it doesn't work anymore. And of course, the units for that is V, right? Because this is direct current. This guy is just V, okay? All righty. So let's look at AC. What do you think AC stands for? We're looking here on problem 3B2 AC. I had to draw it like this because of what I'm going to put in here. So what is AC? Does anybody know that?
Alternating current.
Alternating current. Good job. Alternating current. You didn't know you were going to learn so much the first day. There you go. So an alternating current, in comparison to the direct current, look at the direct current is a straight line. That's supposed to be a straight line. Let me try and see if I can make a straight line. There you go. Alternating current is a sinusoidal waveform or a square wave or a triangle wave. Remember, these triangle waves and these sinusoidal waveforms go on forever. We're just taking one cycle snippet, okay? So in reality, this guy keeps going on and on and on and on, okay? I'm going to erase it because it looks ugly, but it's just a snippet of one cycle. So in alternating current, we actually have an electronic equipment called function generator that creates these three different waveforms. And we will use the sinusoidal waveforms for our AC class, which is the class after the semester. We will use the square wave in digital fundamentals. If you have me for digital fundamentals on Tuesdays and Thursdays, we will be using the function generator for the square wave for the breadboarding that we'll be doing, okay? The triangle wave, we don't use as much, but it's something that it can be done, all right? Any questions and problem on the difference between DC and AC? No? Your wall outlet, is that DC or AC? When you hook up something to the wall, you know, it's AC. Elias says it's AC. So we're talking about this guy right here. Your battery in your car is DC, okay? The flashlight, those batteries in your flashlights are DC, all right? Very good. So now we're gonna move to the 3B3, the DC voltage sources symbol. We saw it over here for a little bit, but I just wanted to show you something, okay? So maybe just show you a little bit. When we're talking about DC, we're talking about one long line and one short line, okay? Sometimes, okay, let me make it in black. Sometimes it has two little lines like this because they're going to be connected to a circuit. But what we're really looking at is just this long line and this short line. The long line is the positive side of your battery. So if you ever see a battery, it has the positive terminal in red and the negative terminal in black. And it doesn't matter how many of these sets you have. So this guy could still be 12 volts, like we said before, or and it can be in any direction. So this guy could be like this, like we did before. And this guy could still be 12 volts or whatever voltage they tell us, okay? One side is positive. It's not positive, negative, positive, positive, negative. No, there is only one positive and one negative. We only look at the extremes, okay? Does everybody see that? I don't want to see positive, negative, positive, negative, positive. Only one positive, one negative. So if you open your battery, There's only one red polarity positive and one black polarity. Yes, and it has multiple cells in there. Alrighty, so you can have it in that direction, or we can have it facing the other way. See how here we have the long line? We could have the little short line, and then we can, this is very important for you to know which one's the positive, the one on the top or the one on the bottom?
The bottom.
The bottom, the long line. Very good. Okay, very good. All righty, so that's how a DC voltage source is. We're going to be working with DC. This is our next class. This is the symbol for an AC voltage source symbol. So right now it's a sinusoidal. So if you notice, half of this guy, I don't know if you know this, but half of this guy is on the top side of the x-axis, which means it's positive. So when that's the case, the polarity is positive, negative. But when I'm on the negative side of my cycle, I'm going to put it in pink, the polarity switches to negative to positive. So it's changing polarity, alternating current. Yes? Okay, very good. So now let's go do our first circuit. So here you go. So a light bulb, just a simple light bulb in your home, requires some kind of voltage. So here's my little symbol, a short line and a big line. Here's my resistor. Here's the switch. So this, just a line like this, is a switch. In this case, it is considered a closed switch. Over here, when it's open like this, I mean, when it's like halfway up like that, it's called an open switch, okay? So here we added all these different symbols that we learned. We kind of got the battery, the resistor, and then we added, so here's the battery, the resistor, we put a closed switch and a lamp. So in order for current to flow in a circuit, there has to be a voltage source and a closed path. So there has to be two things. So in order for current to flow, you need a voltage source and a closed path. So you do have a voltage source, it's this guy, and you have a closed path, which is this guy. You notice everything's closed. There's no open switch. Yes? Therefore, current flows from the positive terminal, from this guy, I, remember the symbol for I, it's a little red row, red line with the arrow, and then a little I, and then it keeps going. It keeps going, and then it hits the light bulb. And as soon as it hits the light bulb, this guy turns on. So my light bulb is on because current flows in a closed path. And so my current continues. So you have learned your first circuit. This is called a series circuit. In a series circuit, the current is the same. Does everybody see that? So what are the two things you need to know? Because this will be on the quiz. In order for current to flow in a circuit, what are the first thing and second thing?
A voltage source and a closed path.
Voltage source and closed path. There you go. This is my voltage source. This is my closed path. My current flows from the positive side to the negative side of the voltage source. This is called the conventional flow. So there's two types of flows, an electronic flow and conventional flow. In electronics, we do conventional flow. In electronics, we do conventional flow. That means the current flows from the positive to the negative side of my voltage source. Yes? What is my voltage source? In that diagram, it's this guy that looks like that. Does everybody see that? The electron flow, which is a different flow, which I'm not even going to write it here, is what physicists and chemists used to think that the current flow, the electron flow. And so in the electronics field, some other guy came and said, no, it's the conventional flow. We go from positive to negative. So they'll talk about that more in chapter 2 or 3. They don't really talk more about it, but basically they just say that we concentrate on the conventional flow. Okay. Okay. So now we're going to do our first problem. We're going to find current in this picture right here. So we're going to find I, and we're going to know that what's given. Given, we have that, we have E is equal to 12 volts. We have a resistor R equal to 12 ohms. And we're going to pretend that this light bulb doesn't have anything, okay? We're just going to, that's not true, but we're just going to pretend that. So R is 12 ohms. So who can tell me what the Ohm's law formula is to find current? I
V over R. Oh, sorry.
E over R. Very nice. E is 12 volts and R is 12 ohms. So you get 1 amp. So therefore, the current flowing across this whole circuit, because it's a series circuit, is 1 amp. Does everybody see that? Yes? So if I went to measure current, and we're going to learn how to measure current later, you will measure 1 amp, no matter if you put your amp meter, we're going to talk about an amp meter, right here, right here, right here, right here, or right here, it would be 1 amp. Because in a series circuit, the current is the same. Yes? Okay. Okay, so here it just repeats itself. In order for current to flow, we need 2 things. And somebody already told me, you need a voltage source, repetition, repetition, and you need a closed path. Okay, any questions? Am I going too fast? I'm going fast? No, okay, Elias, I'm like, yes, no, okay, very good. All righty, so we're gonna do problem number 7. So look at this problem that we did on 4 and look at 7. What is different between those two? You know, it's like find Waldo. What is different between these 2 pictures? It's open, it's an open switch. So look at this guy is different. So the question is the current flowing in the circuit above? Yes or no? No, Elias says no. Adela says no. Austin, I think, says no. Marcelo says no. Let's see the other people. Christopher says no. Very good. So if you said no, you are correct. So this guy is no. Is the light bulb? What is the light bulb? Is it on or off?
Off.
Off. This guy is off because there's no current. Yes, number